So let's do one more example from the homework in section 5.4. So this is question 6 in the homework. And it says that the lengths of lumber the machine cuts are normally distributed with a mean of 89 inches and a standard deviation of 0.3 inches. And part A asks, what is the probability that a randomly selected board cut by the machine has a length greater than 89.12 inches? And part B asks, a sample of 37 boards is randomly selected. What is the probability that their mean length is greater than 89.2 inches? So, at first glance, it might seem like these two questions are asking the same thing. But if you read the questions again carefully, part A is asking about one board, while part B is asking about the mean of 37 randomly selected boards. Okay, so to answer part A, write the probability that a randomly selected board cut by the machine has a length greater than 89.12 inches. Okay, all it's asking us to do is to use the normal probability distribution to find the probability that one board, right, will have a length that's greater than 89.12 inches. So to do that, we're going to use the method of section 5.2, where you're asked to find the probability for a random variable that's normally distributed. So to do that, we're going to go to StatCrunch. Go to the Stat menu, Calculators, and then Normal. Okay, since the question is about one randomly selected board, okay, we're going to type in the mean of 89 and the standard deviation of 0.3. Okay, and we want to know the probability that the length of that board will be greater than 89.12 inches. Okay, so we're going to select the greater than or equal to, and then type in 89.12 in the box, and then click compute, and then the probability goes here. Okay, so the probability that a randomly selected board is greater than 89.12 inches is this number here, and it's shaded in red in our graph. Okay, and we're rounding our probabilities to 4 decimal places. Okay, it's a little more than a 34% chance. Right, but it's 0.3445, right, where the 5 is going to get rounded up to a 6. 0.3446. Okay, so let's look at part B again. So it says a sample of 37 boards is randomly selected. What is the probability that their mean length is greater than 89.12 inches? So notice that it's asking about the mean length of these 37 boards, rather than talking about the mean length of a randomly selected board. So that's the difference between question A and question B. So question B, once again, is about the mean length of these randomly selected boards. So we want to determine if we can apply the central limit theorem. Okay, so you can look up the central limit theorem on page 263, but I've got it summarized here. Okay, so remember, for any population, the sample mean can be approximated by the normal distribution, provided that the sample size is larger. Okay, so usually what that means is if the sample size is greater than or equal to 30, and the larger the sample size, the better the approximation will be. Alright, and if the population is known to be normally distributed, then the sample mean can be approximated by the normal distribution for any sample size. Alright, even if that sample size is less than 30. Okay, so if you read the problem carefully, okay, it does say that the lengths of these lumber cut by the machine are normally distributed. So it doesn't really matter what the sample size is. If it's less than 30 or greater than 30, right, we can still apply the central limit theorem. Alright. So in other words, we're going to use the normal distribution calculator in StackCrunch. Okay, but we need to know that the mean of the sample means is equal to the population mean. Okay, so the population mean, so the mean we put in here is not going to change, right? So the mean of the sample means is equal to 89. It's the same as the population mean. Okay, but the standard deviation of the sample means is given by this formula, so it's the population standard deviation divided by the square root of the sample size. Okay, so according to the problem, the standard deviation of the lengths of these boards is 0.3 inches. So we're going to take 0.3 and divide it by the square root of the sample size. So our sample size is 37. So divide by 37 square root. So that number there is the square root of 37. So we're going to press equal to. Okay, so 0.3 divided by the square root of 37 is this number here. I would say go ahead and round it to 3 decimal places. So the standard deviation for the mean, go ahead and round it to 3 decimal places. So we get 0.049. So that's the standard deviation of the sample mean. Okay, so it's actually smaller than the standard deviation for the population, so 0.049. Okay, and we want to know, right, the probability that the mean length of these 37 boards is greater than 89.12. So everything else is the same. Okay, the remains is greater than or equal to 89.2 stays there. Click compute, and we get the probability. So you can see that it's quite small. It's quite a small probability. So it's not very likely that when you have 37 randomly selected boards, that their mean length is greater than 89.12. All right, and I believe we're rounding out to 4 decimal places, so that 1, which is in our rounding position, is going to get rounded up to a 2. So 0.0072 can be the answer. Okay, and that completes question 6. Okay, so there's one more question in the homework, and it's question 7, and it's much like question 6. So that you can complete on your own. So please let me know if you have any questions, and good luck on the homework.